Welcome to our session on risk and return. This is one class that qualifies each one of you as managers. So as a manager of a firm, you need to calculate the risk associated to you investing in a particular portfolio. So the fundamentals of risk and return are as follows. Analysts would want to quantify risk depending on whether you're looking at one single asset or you're looking at a portfolio. And the portfolio, by definition, is simply a collection or a group of assets put together. So in managerial economics, we want to look at the concept of risk. By definition, risk is simply the measure of uncertainty surrounding a return that an investment would earn. We can say it is a variability of the returns associated with a given asset. Now, a return is simply the total gain or loss experienced on an investment. So you as a manager will need to calculate how much I'm going to earn with the associated probabilities on a particular asset or a portfolio. So we need to understand that there are three types of investors in a firm. The investors that we call risk averse, investors that we call risk seekers. So where risk is concerned, we have people who fear risk. If risk was here, these are called risk averse. They'll run away from risk, so these are called averse. These are investors who only invest when there's no risk at all. On the other hand, there are people who follow risk, and these are called risk what? Risk seekers. And there are those that are indifferent to risk, which are called risk neutral. So all these are the types of investors. You should identify who of these investors you are. So computations of these are as follows. To find the expected return, we simply calculate the probability associated with the return itself. Then when you multiply the probability minus the difference between the actual returns and the expected return is called the variance. When we square root the variance, we call that standard deviation. The standard deviation over the expected return is called the coefficient of variation. So remember, the assumption is that the higher the risk, the what? The higher the return on the investment A. We're going to look at an example of two assets. So we'll be given states of nature. So we have three kinds of states of nature in an economy. You need to understand this as an economist, that there's a time when the economy is doing so fine, there's a time when the economy is not doing well. So these fluctuations are called business cycles. So these business cycles are as follows. At point A, we have what we call a boom. This is when the stock market is at its peak, the economy is doing fine, unemployment is low, interest rates are high, the bond market, stock market prices are high. So the firm will now go into what we call a recession until it reaches point B, which is called a trough. This is when unemployment is high and the economy is at its worst. If this period prolongs for more than a year, it is now called a depression. Now, this depression is a period when an economy becomes prone to bad economic conditions for more than a year. Afterwards, with some resuscitation, the firm now begins to what? To expand. So the downward movement is called the recession or the contractionary phase. The economy is contracting. The upward movement here is called the expansionary phase, where the economy is now expanding until it goes back to point number C, which is now the peak. So these economies are in fluctuations that all economies will experience. You may not live in one state of nature for a long time. Now, we want to calculate the best investment that can be made depending on the risk that is associated with what phase you're at in an economy. There are certain industries that will survive all these economies if you are going to invest, like the pharmaceutical, the education, ammunition, health departments. Whether the economy is bad, people need treatment. War as well will survive economic cycles. But there are economies, or there are certain investments that you need to consider that may not do well. So you need to learn how to diversify your portfolio. So diversification is simply having to have different pools of assets. Some assets are positively and others are negatively correlated. So when you combine these two, you get something that is a straight line. Here, you are trying to even out the risk associated. So that was just to take you through what cycles we have. So suppose here you have a boom, the peak, you have a normal, and you have a recession. So these are the different business cycles that we have. So in these business cycles, to calculate the expected return, you could have associated probabilities. So for instance, you have the chance of having to make a return in a boom as 0.5, in a normal as 0.3, in a recession as 0.2. And we have two assets here. We have asset A, which is giving you maybe returns of 1,000 here, returns of 800 here, and returns of minus what? Minus 300. Then we have asset B, here we have maybe 700 here, then here minus 200 here, here we have 1,000 here. Each of these ones is giving us a total of 1,500. But what we don't know is which of these two has more risk. So we're going to calculate the expected return for each of these ones here. So I'll do asset A and you do asset B. So let me start with the computation of risk calculation for asset A. So we're going to look at asset A. So asset A, we have expected the associated states of nature. So we have SS, which is a boom. We have a normal, and we also have a recession. Yes. 18. So the probabilities that we have here are 0.5, we have 0.3, and we have 0.2. So now we want to go to the returns on each of them. So we have the returns for A. We had 1,000 here, and we had 800 here, and we had minus 300. Now, as we do it in quantitative methods, to find the expected return, we're simply multiplying the probability of what each is times So the return for asset A, we're going to multiply this by that, we get 500. 0.3 times 800, we get 240. When we multiply 0.2 times this one, what are we getting? Minus what?
60.
Minus 60.
60.
When we add this, what are we getting? Expected return for A. What are we getting?
680.
680, good. So the expected return for asset A is 680. Then now we want to calculate the variance and the standard deviation. So the return on A, we subtract the expected return on A. So 1000 minus 680, what do we get? 320. Is it? Then 320, when you square it, what are you getting?
How did you get the 320? What are we subtracting?
We're subtracting 1000 minus 680. 1000 minus expected return is 680. Okay, this is for A. Now we found point A. We simply multiply each of these. This minus that, we get the answer here. Then we square it. Then we multiply by the probability. So help me.
Three 320 squared is 102,400.
You multiply it by what? Probability 0.5. What are you getting?
51,200.
51,200. Correct. The total in this column will be what? The variance. And when we square root it, you get the standard deviation. So let's go. The next level, how do we get B here? How do we get working at B? How do we get the working at B? 800 minus what?
Minus 680.
80, what do we get?
120.
And what did we do to the 120? How do we do the 120? We
squared it.
Right.
To get what?
14,400.
What do we do to the 14,400?
You multiply by the probability.
So what do we get? 4320. 4320. Quickly, what do we get at point C? Anyone else? At point C, how do we get it? How do we get it? Negative 300.
Is it 1060?
Minus what? 680.
Minus 980.
We're getting minus 980. Then what do we do to the minus 980?
We square it.
You get what? $960,400.
Yes.
Then we multiply by what?
0.2.
192080. Yes.
And when we total all these here, what do we get?
Two 201. Oh, I put in the wrong one.
Let's add together 51,200 is 512,200 plus 4320 plus 192,080. So
Yes, it's the same.
then when you square root it, what do we get?
$497.59.
197.497.
497.
497.59.
0.59.
Okay. Then the coefficient of variation, we said we divide the standard deviation over the expected return. So we're dividing 497.59 divided by what? 680 times 100. What are we getting?
$73.18.
3.175%. Okay, or 1.8 is still correct. So this is the risk associated here. So you need to calculate the same for asset B. So asset A has given you this figure. If asset B gave you maybe 80%, hypothetically, we will choose asset A because asset B has more risk. Or you could say, depending on the risk investor, the risk seeker will go for asset B, the risk averse will go for asset A, because the risk seeker will always seek or go for an investment that has what? A higher risk. So you will go and do the same question in the question bank I've given you. First, you need to finish, do asset B. When you do asset B, tell me what the investment, which the investment is riskier. Then,
Collins, just a minute. Can I just take you back a little bit?
okay, let me go through this quickly for those who have just joined us.
Collins.
Yes, please.
Hello. Hello, I wanted to take you back a little bit. I didn't really get the explanation for asset A towards the end.
All right. So
Mhm.
for those that have joined us, a quick recap. We're given two assets, A and B. We want to see which of these assets is more risky. So we've just extracted this part here up to asset A. We want to calculate the expected return and the standard deviation. So this has been extracted as follows here. So we have the states of nature, the probability, and the returns on asset A. So we multiply probability times asset A. Probability times asset A, the total is called the what? The expected return. So part A usually asks you find for each project the expected return. So expected return for asset A is 680. They are done. Part B, they ask you to find the standard deviation. Standard deviation for A. So what you do is we subtract the return minus expected return for each of them. So 1000 minus 680 is 320. 320 squared is 200, then 400. Then we multiply this one by the probability of 0.5, we get the 51,200. Similarly, 800 minus 680 is 120 squared, 14,400. Times the probability of 0.3, we get 4320. And lastly, minus 300 minus 680 is minus 980 squared, 960, 400. Times 0.2, 192, 080. When you add this column, we get 247, 600. This is called the variance. When we square root it, we call it the standard deviation. So the standard deviation for asset A is 49758. Then you'll be asked which of these projects is what? Riskier. So meanwhile, I would have found the asset, the expected return for B and the investment standard deviation for asset B as well. And at this point, you'll be asked to calculate which one is riskier. Using this risk and return model, you need to calculate the coefficient of variation, CV. Coefficient of variation simply gives you the variability, the chances in percentage of how much this asset is varying from expected return. So the assumption is that the higher the coefficient of variation, the higher the what? The margin of error, or the higher the risk in associated with the asset. So when you divide this one here, 497 divided by 680 times 100, you found 73.18. You do the same, the standard deviation for asset B over the expected return for asset B. I gave you a hypothetical example, but I need you to find the actual figure. If you find asset B is giving you coefficient of variation as 80%, your assumption is that asset B has more risk than asset A. Sometimes examiners want to understand whether you understand risk. So they'll ask you to now advise which one of the two investors assets would you advise the investor to go for. So you'd advise based on the type of investor. We've discussed the three types of investors: the risk averse, the risk neutral, and the risk seeker. If it is a risk seeker, you obviously want to go for a riskier asset. If it's risk averse, you'll go for a less riskier asset. If it's risk neutral, where there's no risk at all. So those are the three grounds for your commenting. So I want you to do asset B before the end of the day. Give me the expected return, coefficient of variation, standard deviation. Your actual homework is from the question bank here. You will have to do question number 4. I need you to find me the expected return for each asset, and also to give your opinion which one has more risk than the other. This is 16, 20 marks. So our class ends here. Have a good day.